Well, I think it's about 2 minutes to start, so you can give me that now.
Okay.
I'm Jeff Dilly. I'm at Cal State Channel Islands, the newest and little fighting dolphins. I want to talk small. We've been talking as big as nanobots to make us breathe underwater, and that's mind-blowing and amazing. But there are also small, detail-oriented problems to deal with in marine systems, and we can't forget the details. The devil's always there. What we do is sort of think about physiology from an experimental isolation standpoint. If you have questions that deal with abiotic factors like pH change or temperature change or nutrient availability or load of hypoxia, you need to isolate your organism of interest, you need to isolate your factor of interest, you need to be able to come up with an experimental design system. Your question is only as good as your system. I am an ecophysiologist by trade. My background has been working in hydrothermal vent systems, Antarctic systems, and most recently in California systems. And there is something that links all of those. It is a dynamic system. Even in the California intertidal zone, it is dynamic. Temperature change, pH change, wind change, and you need to isolate them. So I love mussels too. I think they make great systems to work in. And so we made a box. It doesn't look like much from here, but I promise it's actually quite useful. We call them cores, or chambers for organismal response to environmental stresses. And the great thing about them is that they are modular. You can put your organism of interest in, maybe it's not mussels, maybe you like frogs. These things can work with freshwater, they can even work in aerobic systems, you can work in air. They're sealable, they're modular, you can make your input, your output, whatever you need in there. And the great thing about them is that you can do respirometry. So inside here is a patch that actually will read the amount of respiration that's happening in the system on your organism. You can measure stress, you can use respiration as a proxy for metabolism, of course. And the entire thing is sealed. So we have 3D printed parts that are actually circulating the system for water that's in there. You know, it's very important to keep everything moving along fast. So where we are, we have prototypes. We have actually designed and proven this through experimental means. We're going to be presenting some of our data at national conferences in the next coming months. But we are looking to expand our reach. We want to meet with collaborators that have other uses, other ideas. Show us some problems that we can use this system to help you find a solution to. We're proudly pre-commercial right now, but that will change in the future. So we're on the path and we want to help you.
Thank you. Round of applause for Jeff.